Hello friends, welcome to the channel Base Your BTech. As I have mentioned in the first video, this channel discusses with you the 4 subjects from your engineering first year degree, that is from engineering mathematics, mechanics, electrical and graphics. I would like to take all these 4 parallelly in a cyclic way. So please do comment your suggestions and so that I can do accordingly. In the first video, we had discussion about trigonometry level 1 lessons. That was from the subject engineering mathematics. And in the second video, we had the very basic law, that is parallelogram law of forces, from the subject engineering mechanics. So this being the third video, we are going to start with the new subject, which is electric circuits. So this is the course flow for the subject. You can see 4 sections. Actually, this is the syllabus provided by KTU 2019 revised scheme. Okay. In the first section, elementary concepts of DC electric circuits, here we will discuss the basic theorem like KCL, KVL, superposition theorem, and what star delta conversion, etc. And analysis of DC electric circuits is the second section. Here we will have mesh analysis and nodal analysis, etc. These are 200 sure questions coming for your exams. Okay. And the third one is elementary concepts of magnetic circuits. There we will highlight electromagnetic induction, which we had studied in our plus 1 plus 2. Also, we will discuss about MMF, flux, reactance, susceptance, etc. And lastly, we will have analysis of AC circuits. Here you can see 2 branches coming out, that is single phase and 3 phase system. Here we will have a discussion about phasor diagrams. Okay, starting with combination of cells. I have arranged 5 volt battery and 4 volt battery in 4 manners. Okay. That is 5 and 4 volt battery are arranged in series. Here negative polarity of 5 volt and positive polarity of 4 volt is connected together. Here you can see positive of 5 volt and negative of 4 volt is connected. And here negative polarities of both the batteries are connected together, and here positive polarities of both the batteries are connected together. So definitely we will be having a net EMF for all these combinations. Let us see how to simplify this. Okay, when you have different polarities connected together, you just need to add them up. Like 5 volt and 4 volt, here both are having different polarities. The junction has the negative polarity of 5 volt and positive polarity of 4 volt. So please add them up. That is 5 plus 4, 9 volt. Also, you have to follow the same polarity, that is positive connected to A and negative connected to B. Okay. So your VAB will be 9 volt, positive 9 volt. Next comes the second combination. Here also in the junction we are having 2 different polarities, that is positive polarity of 5 volt and negative polarity of 4 volt. Here also you have to add them up because the junction has different combination, I mean different polarities coming up. So it is also another 9 volt, and follow the same polarity like negative connected to A and positive connected to B. Here your VAB will be negative 9 volt because we are measuring from A, isn't it? So A is having a negative terminal coming up. So we have to put a negative for this 9 volt. And in the third combination, you have in the junction you are having same polarities. In such case, you have to take the difference of these two, 5 and 4. Okay, difference will be 1 volt, and you have to choose the higher voltage source. That means 5 volt battery, you have to choose the higher voltage source among these and should follow its polarity. That is, in this case 5 is the bigger number or bigger EMF source. So you have to connect to the terminal A, you have to connect the positive polarity of 5 volt and negative polarity will go to B. Okay, so here your VAB will be 1 volt. Okay, so after having its subtracted value, that is 5 volt minus 4 volt is 1 volt, and you have to next choose the biggest EMF source. Here it is 5 volt, and follow its polarity to be connected in between A and B. Fourth section, it is 5 volt and 4 volt. Here also you can see that in the junction point you are having both polarities being the same. Positive of 5 and positive of 4 is coming together. So what you need to do? Just take the difference among it. That is 5 minus 4, it is 1 volt. Now about the polarity, just choose the bigger EMF source, which is 5 volt, and follow its polarity. That is A connected to negative of 5 volt. So A is connected to negative of 5 volt, and B should be connected to the positive of 5 volt. Now here your VAB will be negative 1 volt, because we are starting to measure from point A, and A is having a negative terminal. So that's about the combination of cells. Next we will move on to combination of resistors. You can see two resistors R1 and R2 are connected in series, that is one after the other. So the net resistance will be RAB equal to R1 plus R2. And here R1, R2, R3 are the three resistors connected in parallel. There we will have the net resistance like 1 by RAB is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, if you are having two resistors connected in parallel, R1 and R2, you can directly move on to RAB equal to R1 R2 divided by R1 plus R2, which is directly got from this basic formula. Okay, but never do like if you have got three resistors, don't follow this pattern, right? Like R1 R2 R3 divided by R1 plus R2. This is Paka blunder. Okay, so never follow this. That formula is only when you have two resistors connected in parallel, like R1 R2 divided by R1 plus R2 is the formula. If you got more than two resistors, please follow this expression, and do not forget to take the reciprocal after you find the value for RHS. Okay, students always forget to take the reciprocal. They just end up in writing the answer for 1 by RAB. That is not the way. Please remember to take the reciprocal of the RHS value. Then only you will get the value for RAB. Okay. That was the very basics that we had on plus 1 and plus 2. Let me give you another viewpoint, that is to identify whether a given connection is a series one or parallel one. For that, I am going to have the terminals for each components that I have. That means for R1, this point is A and here it is B. For R2, B is already taken. Let me mark it as C. So R1 has two terminals A and C, and R2 has two terminals B and C. Okay, and there is no terminals, no branching coming out of this common point C. Like no battery is coming up, or no resistor is coming up, or no capacitor is coming up, or nothing is to be measured from this point like this. No voltmeter or ammeter is to be kept here. Then if that is the case, you can say that R1 and R2 are in series. Okay, what I meant was, if two resistors are having a common point, two resistors are having a common terminal, common point, also nothing emerges out from that common point, then you can say that R1 and R2 are in series. Okay, I will give you an example. R1, R2, R3. So point A and B. Here, what is the relation between R2 and R3? R2 and R3 are in series connection. Why? Because let me mark the points across all the resistors. Like R1, here A is extended to here and here, isn't it? So this point is A and this point is B. Also B point is extended to here also, which means one terminal of R3. And here, since we have come across one hindrance, then you can say, then you want to change the letter. Okay, let us change it to C. And C is coming over here also, and A is coming in this point also. Thus, I have marked all the terminals across every resistors. Now you can identify that R2 and R3 will be in series. Why? Because R2 and R3 is having a common point which is C, isn't it? Other point is different, A and B is different. R2 and R3 only shares one point which is C, and no branches is coming out from this common point, like a resistor is not coming out or a battery is not coming out, isn't it? So we can say that since R2 and R3 share one single point, also since no branches emerges out from that single point, then you can say that R2 and R3 are in series. Okay. Next, what is the relation between R1 and R3? Just like we had in R2 and R3, there is also a common point B coming in between these two resistors, but we have a branch coming out of this point B. So we cannot say that R1 and R3 are in series combination, unlike we had the relation between R2 and R3. Okay. Similarly, R1 and R2 is also not in series combination because the shared terminal A is having some other branch emerging from A. Okay, but R2 and R3 stays in series combination. Why? Because the common shared point C does not have a terminal coming out of it. Okay, so in this circuitry we just have R2 and R3 connected in series. After we reduce this R2 and R3, that reduced value comes in parallel with R1. Okay. Now for explaining about the parallel connection, here also let us mark the terminals, isn't it? So A is coming over here and A is extended to here, A is extended to here. Also B comes here. Okay, B comes in all these 3 points also. Since R1, R2, R3 shares 2 terminals, isn't it? All the endpoints is, terminals across R1 and R2 and R3 is one and the same, which is A and B. Then we can say that all these 3 resistors are in parallel. And next is R resistor value R is connected n number of times. Then your net resistance RAB will be n into R. Also here R is connected parallelly n number of times, then your net resistance RAB will be R divided by n. Okay. Next is a problem for you. We have to find the net resistance RAB. Okay. For this, I am going to mark the terminals across each resistor. Here it is an extension of A. So A is coming here, B is coming here because B is getting extended to here, isn't it? And here also B, here too B. Since one hindrance has come upon, we can change the variable to C. C comes here too. And here also one hindrance of 10 ohms has come here. So let us change the variable to D. D comes here too. D comes here too. Also this point is an extension of A. So we have now marked it. And I will give you a method that if you need to find resistance from this terminal, we have to get the simplified resistive network looking from this end. If you are looking from the left end, you please reduce it from the rightmost end. Okay, whenever you are starting with one end, please move on to the other end and start reducing. So here we are looking through the effective resistance from this side, from AB. So please start from 10 and 15. 10 and 15, you can see that it shares only one single common point, which is C, isn't it? The other point is B and D. So 10 and 15 shares only one point, which is C, and nothing emerges out from this common point. Nothing like a battery or a meter, nothing arises from there. So we can say that 10 and 15 are going to be in series. So what is the series equation? 10 plus 15, that is 25 ohms is coming over there. So I can now replace this 10 and 15 to 25 ohms. Please have the markings also, which means B is extended to here and D is extended to here. Now, as I said, if the two resistors are sharing the same endpoints, like this, 30 and 25 is having one endpoint as B and the other endpoint as D itself. So, we can say that 30 and 25 is going to be parallel. 30 is parallelly connected to 25. Then its values is coming like 30 into 25 divided by 30 plus 25, because that is the formula when two resistors are in parallel. Okay, and the value is about 13.63 ohm. I can have the replacement here also, because 30 is connected parallel to 25, can be replaced like 13.63. After drawing the resistor, please have the markings also. This is B and this is D. Now again, you can see that 20 and 13.63 is sharing one single point, which is D, and no branches emerges out of it. So we can say that 20 and 13.63 are in series. That is why we have addition here. So the value is 33.63 ohms. I will replace it to 20 and 33.63 is replaced with 33.63 ohms. Please have the markings. This point is A because it is just an extension of A, and here it is B. Okay. Finally, again, these are two resistors having same endpoints. So they are in parallel. 15 is parallelly connected to 33.63. Rule is 15 into 33.63 divided by 15 plus 33.63. Your value comes about 10.37 ohms. This is how you reduce a resistive circuit. Fine. Now let's move on to the next topic, which is current division rule. If you have two resistors connected in series and current I is going through it, through R1 and R2, then you can say that current through R1 is equal to current through R2. But if the current is coming and hitting to a parallel combination of resistors, then the current starts to split up. Okay, according to the resistors connected for each branches, the current starts to divide, which means current across current across 6 ohm will be I6, current across 4 ohm will be I4, and current across 3 ohm will be I, and every values will be different. Okay, because the current means a major share of current will be going through the lowest resistive path, which means 3 ohm will have the highest current and 6 ohm will be having the least current. So we need to have a current division rule to find out the values for I6, I4 and I3. Okay, I will give you the basic equation or the general formula. It is like current through branch 1 is equal to main current into net resistance of other branches. Let me mark it as, or let me notate it as RON, divided by this RON plus resistance in the branch number 1. Okay, current through branch number 2 will be main current into net resistors of the other branches, excluding the branch which is under consideration, divided by that particular value plus resistance of the second branch. Okay, I will try to explain using this example. Please see, I6 is the current through the first branch. There you have the main current as 10 amps. 10 into net resistance of other branches means here other branches indicate this 4 and 3, isn't it? We are considering the 6 ohm resistance. So the other branches resistance are 4 and 3 connected to connected in parallel, isn't it? So we will have like 4 into 3 divided by 4 plus 3 because that is a parallel connection. Divided by same value must be copied to here, 4 into 3 by 4 plus 3 plus RB1, which means resistance for the branch which is considered, which means 6 ohm. 6 ohm, we are considering the first branch, isn't it? So there we have 6 ohm resistors and your value comes up 2.22 amps. You can simplify and find out. It is coming like 2.22 amps. Now for the branch number 2, which means a branch having this 4 ohm resistor, you have like I4 is equal to main current, which is the main current, 10 amps is coming, into net resistance of other branches. Other branches means here in this case your values are, this is 3 ohm, right? So here in this case when you are considering this 4 ohm, the other branches resistance means they are 6 ohm and 3 ohm, isn't it? So your value is going to be 6 into 3 divided by 6 plus 3. This value must be copied here, 6 into 3 by 6 plus 3 plus 4, 3.33 amps. Next is the current through the third branch, isn't it? Current through third branch. It is I3 is equal to main current, which is 10 amps, into other branches. Here other branches resistance are 6 ohm and 4 ohm, which are connected in parallel. So we have to have the net resistance, which is 6 into 4 divided by 6 plus 4 divided by the same value should be there copied to the denominator plus the resistor in this branch, which is 3. And there you have the value like 4.44 amps. Okay, I have not written here. This is 4.44 amps and here you had like 3.33 amps. Okay, so this is the current division rule. When a current is hitting to the parallel combination of resistors, according to the resistance, the current starts to split up. Here also you can see that the least resistive path is the 3 ohm path and there you have 4.44 amps, isn't it? Major share of 10 amps is going through the least resistive path and the highest resistance path is 6 ohm. There you have the least current, which is 2.22. And let us check the current which is coming over here, like 2.22 plus 3.33 plus 4.44. It is about 9.99, isn't it? Which means with whatever amount of current is entering the parallel combination, it is getting out of the circuit, isn't it? Here we get 9.9 approximated to 10 ampere itself. So that's all about today's session. Hope you have understood what is taught to you and hope you got some interest towards this subject, which is electric circuit theory. If you got any doubts, please comment below, and if you like the video, please like, share and subscribe it. Till we meet in the next class, this is Minu signing off. Thank you and take care.